Hello, everybody. Thank you for joining us today. My name is Brian Flax, and I'm with the marketing team here at Core Insulation. Today, we will be talking about building and civil engineering with Core EPS. More specifically, we're going to talk about void formers, void fillers, and geofoam. So just a couple of notes before I pass you off to Andrew Butler, who is our Technical Business Development Manager here at Core. We will be recording the presentation today. So if you have anybody you'd like to share this with, or if you'd like to review the presentation at a later date, we'll be sending out the link if you've registered through Eventbrite, or you can find the video on the Core Insulation YouTube channel later today or early tomorrow. There will be a survey that appears at the end of the presentation today. It should open directly in your web browser. We're very focused on continuous improvement and making these events better. So if you have any feedback, whether it's good or bad, please feel free to share your thoughts in the survey. If you have any trouble with it, we'll also send out an email with a direct link to that survey as well. Today's session is worth 1 CPD point. So if you have any annual requirements, feel free to email the address that's on your screen there, hello@coresystem.com. We can arrange CPD certificates to be emailed. If you have multiple people joining today, put all the names in one email and we'll get those sorted for you. And then just finally, we have a question and answer session at the very end. So on Zoom, there is a Q&A function at the very bottom. If you have any questions, feel free to drop them in the Q&A, and I will join Andrew at the end of the session, and we'll go through any questions that anybody has. And just finally, before I hand you over to Andrew, we do have a quick poll I'm just going to put up on the screen quickly. I would just want to get a gauge of who has been to a Core CPD event in the past, or if you're if this is the first time joining us. I will launch that poll. If you wouldn't mind just answering yes or no there. And I will hand you over to Andrew to start today.
Thanks, Brian. Welcome along, everybody. Hopefully you get something out of today's CPD. So I suppose it's a little bit different from some of the CPDs that we've had before. We have some great information put together now, and it's I suppose it's based around a new design guide which we have for void formers and void fillers as well. So I mean, if people want to reach out to us afterwards, you're welcome to do so, and we can share that with you as well. But you'll see some of the extract in it today. So it's a busy time out there. There's lots of projects on the go. It's challenging. It's busy, but it's exciting. Void formers, I suppose, are great in a product sense from our own point of view, and you know what we're dealing with day to day, because everything is different. It's a little bit exciting from the different projects that we see coming through. That's my email address there. If you want to pop me an email at any stage, always happy to help. A fantastic photo. But all right, so we get into the nitty gritty. So EPS and Core and all that good stuff that we're going to talk about today. So yeah, the industry is very, very busy out there at the moment. So I suppose we as a company have been in operation since '97. Manufacturing EPS is our main business from day one. It's a family-owned operation. We're based in County Cavan, but we cover all of Ireland and the UK. We're a guaranteed Irish company, and we were the first company in the country to have all the ISO up-to-date standards, so the 9001, 14001. So we kind of, as Brian was saying, we you know, at the start, even about trying to get feedback, we're always trying to push ourselves, improve ourselves, you know, and look at all the things that we do. So what are we going to talk about today, and what are we going to go through? So just a little bit of, I suppose, a cover of what EPS is. I'm sure there are people on the talk today who are familiar with it, but no harm covering it again. Looking at the design of void formers using EPS, you know, what kind of EPS we're going to choose for a project, because there are different types. We look at some of the examples of design, which are coming from our new void former design guide, and some real life world case studies, you know, looking at how we've used EPS void formers on different projects. So you're going to hear a lot of EPS words today. EPS, EPS, EPS. So what is EPS? It's essentially expanded polystyrene. That's what EPS stands for. And how does it come about? So when we're, I suppose, manufacturing, and as I mentioned, we're an Irish company, we do all the manufacturing in-house. When we receive the material from the raw material manufacturer, it essentially looks like a sugar. And what we do is we use steam and we use heat to expand it, and we put it into this bead form. After it comes to a bead form, it stabilizes and matures in large silos. We can use the bead for part of our cavity wall insulation. But what we can do with the bead then is take it to the next step, which is molding. So you can see these large blocks. There's a small block there, but you can see these large blocks that we make with the EPS. And depending how much weight of material per cubic meter decides what density of material is. And you'll see as we go through the presentation, the different types of EPS that there are, and where you might use them. And you can see there's two colors that we do, which is a silver and a white. Generally, when we're looking at the void formers, the vast majority of the material that we look at is of the white type. So that's a little bit about it. The manufacturing process itself, we don't use any gases in the production. So there's no gases pumped into the material to achieve certain things. So it is what it is when it comes out of the factory. There's no gases there. And when we look at recycling, we recycle a lot of our own material in-house, which is good to know. So getting straight into the void formers, what is a void former? Why would you use it? Depending on where you are in the, I suppose, the construction process, where would it come into your world? Why would it be chosen for a project? So basically, EPS void formers are used extensively throughout the construction industry for a lot of major works. We use them in motorways, underpasses, shopping centers, use them in foundations, embankments, and that kind of thing. Core void formers, they're suitable for domestic and commercial applications. We see them used in residential developments regularly also. The EPS can be utilized for a variety of void formers and void filler applications. We can decrease the volume of concrete or increase the strength of the concrete by using a void former. The core EPS is that we have various ranges of compressive strengths in the EPS. So, depending on what the project requires, we should be able to fulfill it with an EPS product. So part of I suppose, the important stuff around the background information that we have for our EPS. So as I mentioned at the start, we have a new design guide. So this is our new design guide, and basically takes through a lot of information about the material itself, the things that people need to be aware of when we're designing and using it in a project. We look at some of the examples of using the EPS in various scenarios, and we look at some of that now today as well. Testing, and I suppose giving people confidence in the EPS and what it does, and proving that it's going to do what we say it's going to do. We test all our EPS materials in-house, but we manufacture to various EN standards. So the main one that probably people would be more familiar with is EN 13163. So this is around the thermal performance of EPS. And there's a lot of information stated when we test that, and that's stated into our declarations of performance and allows us then to have our CE marking for the material. But when we're looking at using EPS in the civil engineering and building in a different form, we also test and specify a DOP for EN 14933. So this is more about how that insulation is going to work in the civil engineering aspect of things. So we've those DOPs for the two types of ENs available. So that can give people confidence in the product. As I mentioned, we have CE marking there as well. So void formers, void fillers, geofoam, they're similar, but they're different. So just to talk a little bit about the differences in them and the different applications, most people would just associate them or call them a void former, but they're slightly different. But we're using EPS for all of these. So a void filler, it's basically a simple EPS solution to raising your floor level prior to pouring a concrete slab. We can manufacture the EPS, whatever thickness and size that's needed on the project, and blocks to help make that project a success. The product is used on new build and also repurposing of existing buildings. So that's just a typical sheet of a white EPS there. And here's some examples of, I suppose, buildings that it would have been used in. So we've used car showrooms where, you know, we have heavy weights on the floor under the concrete slab. We have the combi lift factory in Monaghan there. Again, you know, large equipment being manufactured, heavy weights moving around on floors. So we've EPS in there. And even you see it raising heights for underfloor heating, maybe some thermal performance. That's a project there in Shelburne Road in Dublin 4. So various uses in floors. When we're looking at void formers, we're getting into maybe some more unusual shapes and then more unusual type of projects. So you'll see here, we're just going to show you some of the typical uses that we'd see coming across our emails for EPS and some of the requests that we get. So we can use EPS for an arch void former. So again, EPS being lightweight, we have a known compressive strength of material. We can use that material on our projects. We can use them in ramp void formers. And again, lightweight, easy to work with on site. And again, you see, you know, there's different shapes and sizes, and all these shapes can be cut specifically to the project. So none of these are off the shelf type products. They're specific to the project that they're being used on. Column formers would be another one, which we see occasionally. And again, you know, it's down to the shape, down to the size that the customer wants. This is a very, very popular void former, which we'd see coming through from our customers. Secant piles, looking at the wall construction, basements, obviously large sites, especially when you look at Dublin City now, large buildings being pulled down, you know, we're going down further into the ground, we're using piles. We would see a lot of EPS being used for, you know, sacrificial purposes for creating the piling there. And again, these are specifically made to the customer's requirements. They come to us, they give us the size, we can work out the material for them, manufacture as per their spec, and also supply them with installation drawings and a lot of information as well. And this is just I suppose, a snapshot of some of the other ones. So, you know, trough molds, various slab requirements. You know, if somebody wants to reduce concrete in a build-up, we can use a void former that you know, as per the specification, the size that's needed on the site. Even just temporary rail platforms, all sorts of weird and wonderful shapes can be accommodated with EPS. That's the beauty of it. So it can be profiled and shaped as the project requires it. So a void former would normally relate to the piece of EPS that's been used along with a concrete, so under concrete. Again, these would be a lot of the time be referred to as void formers as well, but we're starting to refer to them more as geofoam. So it's basically an EPS material used in connection with civil projects or whatever it may be that's involved with being used under the ground, under soil. And here's some examples of it. So, you know, one particular use could be slope stabilization. And we've seen some projects over the last few years with EPS being used there. And because it's EPS, we know that even if the EPS comes in contact with moisture, it's not going to be affected. So your physical and even your thermal properties are not going to change with moisture. So that's one of the really good things, and why EPS would be used in a lot of civils projects. You can pour the concrete straight onto it. That's not going to affect it. It can be completely immersed into water, and the physical property of the EPS is not going to change. So you can see how it can lend itself to a civils project. Road embankments would be another one. Years ago, the EPS was used under some of the railways in the boggy land around Ireland, because of the fact that, you know, it doesn't break down over time. It's a material that, you know, once you design it day one, based on your loadings, based on the project requirements, that physical property is not going to change. It's going to perform the length of the requirement. I suppose now we're going to get into a little bit more of I suppose the technicalities around EPS and some of the things that we need to be aware of, and even from a general point of view on a project. And this is coming into some of the information that's going into our Void Formers design guide, and we've extracted some of that again just to give people a flavor for what's in there, because there is a lot of information. We can't cover everything today, but we'll show you some of it. So things to be aware of, and again, the things to be aware of that people would consider with a project, and then they think of EPS and say, well, okay, my box is ticked there. I know that I'm safe here by using EPS. So resistance to water, I've already mentioned that on the last slide. So we've a low factor of water absorption, short and long term, when we look at an EPS. So it doesn't lose that physical performance. So if you use an EPS, you'll have confidence in that project that the compressive strength that's stated in your DOP from core is going to maintain over the lifetime of that project. Other materials may not stack up quite the same. So EPS is definitely a lifetime use. Freeze thaw. So it's again something just to be aware of. Determination of freeze thaw resistance is only needed for applications where EPS is permanently exposed directly to water. Temperature range is below 0. These conditions can occur in non-protected frost insulation systems, so where we've no gravel layers or insulation underground or inverted roofs. Just something to be aware of, something that we consider, but the resistance of EPS to freeze thaw is very, very high. And we look at the EN 12091, this standard measures the compression and the water absorption under conditions from -20 to +20 in wet conditions. And EPS performs very, very well in that. So if we looked at freeze thaw in masonry, obviously we all know all about that at the moment. There's a lot of talk in the industry. It's not so good. So EPS performs very, very well there. A regular question we get, is about vermin. If you're burying an EPS in the ground, is this an issue? But the EPS, because it's a synthetic type of buildup, it doesn't have an attraction to any vermin. It doesn't, and it also doesn't promote the growth of microorganisms. Chemical resistance. So I suppose just consideration needs to be taken if we're using EPS in a soil, if it's around a road where there may be a possibility of a fear of a burst of chemicals and fuels in a close proximity to the EPS. We need to think about maybe a separation layer that it doesn't affect it. So these are just some of the, I suppose, the considerations that we look at when we're designing. So these are the different types of EPS. So 70, 100, 150, 200, 300. These figures at the end basically refer to the compressive strength of the material at 10% compression. So EPS 70 is 70 kPa to make that material compress by 10%. So if you had 100 mil thick, that's the amount of pressure that it would take to bring it down to 90 mil, so compressed by 10 mil. So there's a lot of information when we test and we look at the EN code. So EN 13163, which I mentioned, we looks at a lot of testing information and what the information that we test on our DOP. So we look at dimensional stability, we look at the durability and the thermal resistance of the product over time as well. So something to be aware of when we're looking at EPS, and equally any other material that's out there, is around the structural designing of the material and its fit for purpose on loading. So really, when we're looking at designing something to compress 10%, it's too much. So we need to apply factors and look at the 1% compression of the material and how it stacks up. Because we're testing to EN 13163, we can categorically state the compressive strength of that material at 50 years. And again, we factors for that. So again, we discuss all that in the design guide, but it is something to be aware of, because maybe some people may not be overly familiar with that, because these are the way that everybody states their performance as per the codes. But we do, when we're looking at the structural design, we need to have those factors in mind. Also, we may have projects where we're using a void filler, and it could be just an EPS sheet, but we need also a thermal performance from the material as well. So as you kind of cast your mind back, start of the the slides, we had the silver and the white EPS. So the different densities of material and different types. So the silver would have a lower thermal conductivity. So you see the thermal conductivities as different types of EPS there. And obviously we can work out U value requirements, but that can be an application. Obviously, if we're looking at something like in a geofoam point of view and something going under the soil, and it's not part of a building construction, there is no thermal consideration there. But if you do have one on a building where it's part of the structure, we can help you with that, and we can look at it as well. So just, I suppose, some of the different bits of information that are stated on the DOPs, and this is an extract from one of our NSAI certs, our argument certs for our floor material. We state the thermal conductivities, the tolerances for the shapes of the materials, compressive strengths, the flatness, and information about the long-term, the short-term behavior of the material when it comes to moisture. So you can see the reference there again, this EN coding. And that's just a bit of information as well, if people were interested, how do we achieve the different strengths of EPS? So if you look at EPS 70, we have 15 kilograms per cubic meter of material. But when we get up to EPS 300, which is very, very dense, takes much heavier loadings, we have 40 kilograms of material per cubic meter. So you can see how the material can take an extra bit of weight. Right, we're getting into the nitty gritty more so of our design guide. So as I mentioned, this design guide that we have, and I think we're pretty certain we're probably one of the first people out with something like this, certainly in Ireland. So we would get a lot of inquiries from engineers, structural engineers, contractors, architects, asking about void formers and how do we go about designing them, what things do we need to be aware of. So we put this together over a long time, along with the assistance of a structural engineer, to put information into one document to help people out. So some of the things that we need to consider as part of our normal design, and we have information and we discuss them. So one of the first things would be the modulus of subgrade reaction. So the thickness and the grade of the EPS void former would be used to calculate the modulus of subgrade reaction, which is the K value. That's used to calculate the deformation of the EPS under loading. So the equation which you see there is used to calculate it. If the void former is positioned onto soil, the K value of the soil can be combined with the K value of the EPS using the formula that you see there, so the combined one. The K value of the soil can be sometimes provided by whoever's doing the site investigation. What is more usual, and we see a lot of the time as well when we're looking at various projects, is that the void former might be used on a structural slab. So this could be repurposing an existing building possibly. And at that, if we're looking at it from that point of view, the K value of the EPS would be used on its own. It also would be conservative to only use the K value of the EPS void former on the soil, because the more the ground void former combination safely deforms under a pointer line load, the more the screed is mobilized to support the applied load. So that would give us a greater capacity. So concrete specifications. So this is obviously vitally important. And I'm sure most people are very familiar and very capable when it comes to this, more so than myself. But I suppose we look at this as well in the design guide, and when we get into the example now, and we're starting off in the next slide, you see how it works in with the EPS. So when we're looking at the concrete spec of the screed above the void former EPS, or the slab below, it depend on, I suppose, the exposure class for the concrete, and that might have an effect on your cover requirements. So the specification should be in accordance with EN 206, which is the normal enough concrete spec. The presence of the void former has no effect on the concrete spec unless it is in a position where its insulating properties can protect the concrete. Otherwise, it will be exposed to freeze thaw. Factors of safety, something else that we need to be aware of. So loadings will be as per EN 1991. The factors of safety will be used of the void former, and concrete will usually be as per EN 1990. This standard would give different factors for different combinations. We also look at the EPS white book, which would suggest a material partial factor of 1.25. However, since EPS, it's manufactured in a controlled environment. We do it under EN codes 13163. It's more of a predictable material than the soil. And because we're regularly testing in-house all of our material in the factory, we would feel when we're looking at the calculations that a value of 1 or 1.05 would be more appropriate. So a value of 1 is used in the design guide if you're actually looking through it. So this is one of the examples. So what we're going to do is we're going to look at a combination of the screed and then also the void former or the void filler below it. And we're going to check to see how it works, and if it doesn't work, what do we do then? So in this example, we're taking a 20 kilonewton point load, which is 12 kilonewtons dead, permanent load, and an 8 kilonewton imposed load. It's going to be applied on a 50 millimeter thick C2530 unreinforced screed, and we're going to put it onto 100 millimeter thick of an EPS 100. Our 20 kilonewton point load is going to have an effect. So we need to look at the screeds. We're going to look at the insulation and see how everything works together. So we're going to assume for this case that the load is applied away from the edges or the corners. And we need to check the screed, the insulation combination can support the applied load. So if we look at TR34, fourth edition is where we took this information from, and we checked the screed. So you can see the calculations there and the equations that we're using and the information that's been plugged in. I'm not going to go through every single figure in this because I'd probably put people to sleep possibly. And I don't want to trip myself up, to be honest, especially when you're talking to loads of people. So yeah, so you can see the calculations that's done there and how we're checking the screed. So the important things, the loads being applied away from the edges. And we're checking the combination of the two materials together. So there are standard enough scenarios that we would see on a standard project. So again, looking at our equations, we're looking at our check of our screeds. We look at our design loads and we see where we need to be. So when we actually look at this combination of information that we have, so we have our moments of capacities of our unreinforced concrete, and we do our check on it. And it turns out that the screed is not suitable. So if we've checked the screed, have we checked our insulation? So then we need to look at the insulation check. So again, we're looking at our K values. We're looking at our K values here. We're looking at our calculations, or plugging in all the information that we have from our projects. We're looking at the compressive stress from the point loads. We know that the material itself, the insulation, so if it's an EPS 100, we know that the factored load, so EPS 100, it would state in our DOP that it's 100 kilonewtons per square meter, or 100 kPa is the compressive strength. But if you cast your mind back to where I showed the factors that we apply, 0.4 factor to that would state that our short-term compressive strength, to give us 1% compression on that material, our maximum is 40 kPa. So you can see when we look at I suppose the movement of the loading through the screed to the EPS is coming in at 49 kPa. So therefore, we're above the allowable compression of the EPS 100. Therefore, the insulation is not up to the job. So at this point, screed and the insulation, we've shown that they failed with the arrangements that we were looking at. So we need to maybe say, well, which do we need to look at first? So in this scenario, what we do is we look at the screed. So is the screed strong enough to take the supported load? If it is, well, then we can recheck our insulation to make sure that's not overstressed, or do we need to go thicker or stronger, or whatever the case may be, to get that spread of load, sufficient spread, and make sure the insulation isn't overstressed. So I suppose other things in the background could be, if we're using a semi-hydrate screed, they have very, very high tensile strengths. more so than standard concrete, but it depends on the manufacturer and the type of screed that's being used. So obviously we need to check all these things as well. If it's, you check with the manufacturer, they'll obviously have their information. So what we're going to do is we're going to do a recheck, and we're going to come back at our calculations again. And what we're going to do is we're going to increase the thickness and the strength of the screed. So we're going to a 75 mil thick screed, and now we're upping the grades to C2835. So when we plug in the information now again, we're going to check our screed. So because the values are working out the way that they need to be, our screed is now suitable. Because the screed is now suitable, we have our figures from this, we can do our check on our insulation. So remember, our EPS 100, our short-term compressive strength with our factored loads tells us that 40 kPa is the maximum that we can take to give us 1% compression. As you can see here, the load's coming in at 27.6, which is less than our 40 kPa. Therefore, the insulation in the short-term check passes. So we now have a case that the insulation passes and the screed passes. So that all stacks up. We need to do one more check, and that's the long-term. So we've shown the insulation screed are now suitable for our project based on the loadings that we have. So balancing between the two, we didn't need to change our EPS, our material below the screed. It was just the screed that needed adjustment on it. So long-term check. So as I showed you earlier on, so if we have 100 kPa for EPS 100, our short-term factored load to give us 1% compression is 40 kPa, but our unfactored long-term check and our long-term 50-year compressive creep figure to give us 2% compression would be 30 kPa. So we do a check against that as well. And when we do that, we take our dead loads. We have these unfactored. We look at the material itself, and we come in with a figure of 12.6 kPa, which is less than our 30 kPa, our allowable stress. So that's that factor of 0.3 against the EPS 100. So therefore, our insulation passes in the long term. So there are more examples in the design guide, and obviously there's a lot of information just purely in the calculations, which I'm not going to go into today because we could be here for a long time. But that's a flavor of what's in there. So you can see how useful the information is in the design guide, and it takes us through all the things that we need to be aware of. And it's good, I think, that it shows when it goes wrong, how you can adjust things. So we look at some case studies here as well. And hopefully, again, you will find these of interest and give you a flavor of what we can do with EPS, and how versatile it is for the different projects that are ongoing. So this was a bridge project. Core provided BAM with 192 linear meters, or it turned out approximately 55 void formers at 3.5 meters long. And it was being used in a bridge deck. So the EPS void former was used to reduce the weight of the concrete on the bridge deck, and we're left in situ. So when obviously the concrete was poured, the EPS was left there. The EPS void form was used along with a 50 millimeter neoprene buffer, between the bright strap and the contacted area of the EPS. As you can see, some of the drawings and the details and some of the pictures from the project there on the screen as well. So this provided BAM with a cost-effective solution to their project. So vastly reduced weight of concrete. So the structure was able to work that little bit easier for them. Reduce the weight on the bridge deck. And then because it was an EPS, because it's going to be left in situ, they knew the long-term performance of the EPS, and EPS has been on the market in its current form for 70 years. So it is around a long time, and it is a proven material. So that project was very, very successful for them. Obviously, they came to us, they gave us the size of the void formers that they needed. So as you can see, they were cylindrical. We would make them to millimeter accuracy, whatever the project dictates. So that was a very successful project to be involved in. a different one. Again, just to give people a flavor and what can be done with the material. This was a hotel ramp just off the Marion Road there, for McAleer and Rush. So essentially, they had a ramp inside, obviously for car park access, on a slope, on a radius, and they were looking at using EPS. So they started off with a flat slab, and then to bring up their ramp to the level that they needed up to the next level, floor level up. So they came to us obviously with their construction drawings. They said, well, we need to fit between this line and this line. It needs to take the radius here, it needs to take the radius here. But at the same time, we're having a rise obviously in the ramp. What can we do for them? So you see here on the next slide, I'll show you some photos from the project itself. We broke it all down into obviously blocks and EPS blocks. And you can see here the level of detail we can go into and what we would supply to the customer as well. So we take it obviously from near enough a 0 point up to, I can't remember what the exact end height was at the end of it. But, we're climbing, taking the radius into account, working within the structure that's there, allowing them to form that ramp, because it's EPS lightweight material. The structural engineer works out the compressive strength based on the EPS that's been chosen for the product, works fine for their loadings, and off they go. So we manufactured and we supply them with these installation drawings. And again, to make life very, very simple on site. And because it's within a building, and the material was able to be placed very, very simply because it's lightweight EPS. And you can see here, this is a typical example of what we would provide the contractor. So everything is numbered and they know where everything needs to go. It's follow the numbers. Every piece is manufactured as per is shown on the drawing. So they very, very little work to do on site bar placing it. So these are some pictures from the site itself. So there's the EPS material obviously going in place, the mesh going in, steel reinforcement. So obviously there's the ramp coming up from the car park level below, and then the finished concrete. So very, very handy from the contractor's point of view. Less concrete, so less embodied carbon. I mean, we must remember we have an environmental impact in everything we do these days. We need to be careful of our environmental impact. Less concrete is good. EPS is 98% air. It is recyclable. It's quite a sustainable product when we compare it to some others. So that's some pictures from the site itself. Another one. This is the third one I'm just going to show you here. It's basically this is more the Geofoam application. So we've looked at EPS being used under concrete. Could be a void former, void filler, but this is more the Geofoam application. So this was a project in South Dublin for HML, large development. So they had various attenuation locations around the site. Obviously, there's the attenuation type material there. DBF, I think DBFL were the engineers on this one here. So there was the attenuation, and then they were using EPS there. You can see it in this triangular form here, to above the attenuation tank to create the slope and the landscaping that they needed. So they came to us again. It's a similar thing. We need this kind of shape. We supplied the information, the compressive strength of the material. The engineer was able to work out, well, I need this density of material. Is it an EPS 70? Is it an EPS 100 that I need here in this location? Obviously, if it's very, very highly loaded, we can go higher again with the different grades of EPS all the way up to EPS 300. So when we manufactured the material, again, it's very specific to the site. And again, to make life very, very simple for the contractor. So, we would provide them with drawings, a breakdown of the material, all the pieces numbered. Again, it's an installation drawing, and very, very simple from the site point of view to actually place, because it's a lightweight material. Even in large blocks, a lot of the time it can be manhandled into position. So they come to us with their footprints, the slope that they need. We make it up into EPS blocks and pieces, and various layers if it needs to be done in layers, and give them all that information. Very, very simple in the end from actually placing it on site. So again, there's just some pictures from site, and you can see how it just works together. It's one of the numbers there. Yeah, so you can see the versatility of the EPS and how we can shape it, do all the projects that we're involved in to date. And we're seeing more and more of it being used on projects, certainly in Ireland and the UK. Void formers, the benefits are being seen to their use on the different projects. Even over the last years, a lot of repurposing of buildings, and as different changes of use are happening. So hopefully that'll give you a flavor of, what you can do with the EPS. If you have a project, if there's specific use, we can make it to suit, and we can overcome that and help you deliver your projects a lot easier. So just the last few slides and a few little bits of information, I suppose, just for people to be aware of. EPDs and as I mentioned about sustainability, the less concrete we can use, the less embodied carbon that we have. So we were the first board manufacturer in Ireland to have an EPD, which is an environmental product declaration, and that's worked with the Irish Green Building Council to attain that. And essentially what that means is it states your environmental impact of your material from when you receive your raw material all through all the manufacturing to have it produced and it's going to site. So there's a lot of information in there. But what has happened over the last few years is certainly government-led projects and local authority-led projects, and we're seeing it more coming into the private sector now, where specifiers, whether you be an architect or an engineer, looking for a product that has an EPD. Because if we're using the likes of LEED or BREEAM software to work out our energy performance of the builds, if you have an EPD or product with an EPD, you get there easier, you get greater credits with that. So you can see that coming more and more to the front with a lot of projects now. So we have that, and it's a great thing to have. And also I mentioned that we do recycle EPS, which there's a lot of other materials out there that you can't recycle. So we're at the moment we recycle material in-house, our own material, but we've also started doing some test sites. So we're taking back material from site and recycling it as well, and we're hoping to grow that over the coming years as well, and do our bit as best we can. Just on our technical services, and this is the last slide now, what we can do for you. So I mean, I head up our technical department, so I'm always available if there's anybody out there that wants me to come and do CPDs. That's always an option. We have various different CPDs, simple things like U-value calculations. We have our CE marking, our NSAI certs for various products. We have our declaration of performance for all our materials as well. If somebody was looking at more thermally stuff like the condensation risk analysis, we can do that for you too. We would also have a lot of details, AutoCAD, BIM, and PDF. So even if you were looking for Revit files, they're on our website, you can download them. The on-site visits, if somebody wanted to see material being used, we can organize that. And even on our website, we have a resource center there that you can access a lot of information. But I mean, it's as easy to contact myself or my colleagues directly. We're always happy to help. But hopefully we can give you the confidence that you can see that Core can help deliver your projects timely, efficiently, and in a manner that will potentially save some money on the project as well. And that's me. That's just obviously my contact details there as well. So feel free to reach out to me. And that's it. I think Brian we might have a few questions, possibly. I don't know.
We do, yes. Yeah. Thank you, Andrew, for that presentation. That was very interesting. We talk a lot about in previous EPs about the thermal benefits of EPS, for foundation systems and floor insulation and wall insulation. So this just goes to show, kind of the versatility of EPS as a whole. Can be used for these void former filler and geofoam applications. It just proves that it's a very versatile material. So we do have a couple questions. I guess the first, we talked a lot about the benefits of EPS itself. Could you talk about maybe a little bit about the benefits of the on-site benefits? So what the contractors on site would benefit by using EPS as a material?
Yeah, sure. So I mean, one of the great things about EPS, it's very simple to work with. So even if you were looking at a sheet material, and trying to work it and cut it on site. It doesn't have a dust off of it. It's very, very simple, easy to work with. From the contractor's point of view as well, when, say, if it was something like a void former, where we're getting more into an unusual use, that's not just a sheet that has a profile to it, a shape, it's the information and how we can provide that to the site. So as you can see from some of the ramps and things like that, like we will cut the material specifically to that job, to the shape that needs to be formed. So it's about making everybody's life easier, because time is always an issue. Labor is expensive on sites. So the easier that you have an installation of something, and that will tie into our foundation system as well, and how we give the material to site. So we would give an installation drawing. The pieces are numbered. It just makes the contractor's life very, very simple. And I suppose the great thing at the moment is, certainly from ourselves, in terms of material supply, and it's the industry issues at the moment about trying to get material to site. We have a really good supply of EPS and raw materials to manufacture it. So we don't see any issues there, and we should be able to supply projects into the future. No problem.
Great. And I guess I know you talked briefly at the beginning of your presentation about kind of the differences in the compressive strengths. Just a question here. What would something like EPS 300 typically be used for, some of the higher densities?
Yeah. So as you saw from the different types of EPS 70 all the way up to the EPS 300. So the calculations that we looked at there, we looked at an EPS 100 and the point loads, and that could be maybe I suppose translated into maybe a wheel load from a vehicle. But if we had, I suppose, more heavy loads, if we had bigger point loads, if we had large structures coming down with larger loadings, the EPS 300 would be called into play then. So when we looked at the likes of that even the slides I did with the combi lift factory and the car showrooms, where I suppose you have more stationary heavy loads coming onto a slab, if maybe in that case, we will start to see the EPSs, the 200s and the 300s being used. It's where we're going to have more heavy concentrated loads. We're going to see those EPS 300s coming in there. And again, because we have the DOP and we've all the testing there, because we test all the material regularly to prove that the compressive strength is there. You can use it and you can say, well, I have this heavy scenario. I can use the EPS and I know it's going to do exactly what it's supposed to do over the long term of the project.
Another question here. Are there any considerations using EPS under clay or soil that people should be aware of?
Yes. There. I suppose the only real thing. So EPS is great when it comes to dealing with moisture. As I mentioned, we see it used as pontoons, flotation, all sorts of things in the ocean, and no issue with it. You can put it under the soil. The soil's not going to affect it. You can put it under concrete. Concrete's not going to affect it. But it's just to be aware of, petrochemicals, fuels, oils, that kind of stuff can have an adverse reaction to if it's come in contact with the EPS at that location. So if it's at a point where there's a risk of a close proximity, so if it was in a road embankment or under a road or under a rail line or something like that, where there was felt that maybe there's a potential for a leak of some sort along the line, well, then a separation layer would be recommended in that case. But that's really all that's needed.
And just a final question here. I know you had talked about this within your presentation as well, but could you give some examples of using EPS or void formers when you're repurposing buildings?
I can, of course, yes. A well-known one is the Old Central Bank site in Dublin City. So there's a change of use there, and everything is being changed, and there was basements, and they're bringing up floor level. So you're using an EPS void former, say 300, 500 millimeters, and putting in new concrete podium slabs, that kind of thing. And we regularly see EPS being used there. There was also, let me see, the over in South Dublin, we had, so obviously when the crisis, the recession happened 2007, 2008, there was a lot of buildings mid-build, and at that time there were offices and commercial type builds. And what happened was the contractors went back in later, reapplied for planning permission, and we're starting to change them into apartments. And they were, again, changing levels, kind of getting everything more uniform as opposed to the commercial type builds. And there was a lot of EPS void formers used there, obviously under concrete, to change the floor layouts, to regularize the shapes. We even had one only just recently as well in the old Cleary's building in town. Again, things are being moved around, things are being changed, and that's a regular use for EPS. And because the beauty that they'd come to us, so the size was be very precise. So I want 5.65 square meters long by 3.47 meters wide by 1.02 meters deep. We can supply the EPS exactly as per that specification, and it just makes life so easy for them.
That's great. So we did have another question come in here. This one may be a bit too technical to answer live, but if you want to send, let's see, can EPS?
Actual site measure versus engineers drawing. Well, that hopefully by the time you get to the top of a skyscraper, it's within relative tolerances. But what would happen a lot of the time would be, yes, that even when it comes to new builds, which say the void formers being used around columns and all sorts of things, you at the initial stages, you might have the engineer's drawing, which would have a certain dimension on it. But what would happen a lot of the time, the contractor themselves would actually take a site measurement if the structure is up already and they're trying to fit in, just to double check. So that would be a regular thing where, I suppose, before they go to manufacturing, that the contractor might want us to wait for their site measurements. That would be a regular thing, yes.
Perfect. So that should wrap us up for today. Thank you, Andrew, for the presentation. I thought it was very informative. Again, to all of the viewers and attendees out there, there will be a link to this entire CPD available. We will be emailing it around. Again, just a reminder, there is a survey that should appear in your web browser once you close out of the session. If you could take just a few minutes to give us some feedback, we would really appreciate it. And again, if you need a CPD certificate, this session was worth 1 CPD point, you can email us hello@coresystem.com. We'd be happy to arrange for a CPD cert. So again, thank you for attending today. Thanks, Andrew, for the very informative presentation.
Thanks, Brian, and thank you to everybody who came along. We really appreciate it.
Thanks, everyone.